All right, so now we're ready to think about some points here. And the first point that we want to think about are any roots. Where are we intersecting the x-axis? And if we have a fraction, right, it's going to equal 0 when the numerator equals 0. And so let's check the numerator. The numerator is x plus 3, so you can quickly probably see that the numerator is going to be 0 when x is minus 3 or negative 3. And we'll say that's right here, negative 3. And I'll plot a point. Now, you might say, well, that's not okay because it's touching our horizontal asymptote. But I want to point something out. And I would recommend you pause and try and think about this yourself. Why is that okay? It's okay because the horizontal asymptote just says what's happening as x approaches infinity. What's happening as I get really far out there on either side. And it doesn't say anything about what we're doing at negative 3. In fact, all it's saying is, hey, as you get really large values of x, you're going to get close to 0. It doesn't say you can never touch 0, unlike the vertical asymptote, which says you can never have an x value of 2 or negative 1. The horizontal asymptote just says as you get very, very far out, this is the point, the line that you're tending towards. It does not prohibit us from having an x-intercept here, okay? Because this is not close to infinity. Negative 3 is just a number that's actually pretty close to 0, and so it's totally okay for us to have a root here. Okay? So now that we're okay with that, we also want to consider the y-intercept. What happens when we plug in 0 for x? And if we do that, we're going to end up with 3 over negative 2, which is going to be negative 1 and 1 half. And that's, I've got, a lot of points here that I kind of know, right? Let's make a little chart of the x values where we know where our function's at. So we know where our function's at negative 3. We know it can't be at negative 1. We know where it's at 0, right? We know where that's at. And we know that it can't be at positive 2. So that's a lot of values. And on top of that, right, we know that it's tending towards 0 in both directions as we get further and further out. So now let's just consider what's happening on either end of our critical points, right? Let's first start on the right side. Let's think about what's happening to the right of positive 2. Well, to test that out, right, why don't we just consider what's happening at 3? So if you plug in 3, you'd get a positive number, 3 plus 3, over another positive number because you'd have 9 minus 3 minus 2. It's a positive number. It's some positive value. So I'm just going to mark down that it's going to be positive here. Now think about what that means. If at 3 I'm positive, can I ever go below? Can I have an x-intercept here? I can't have a root because I've already found that my root only occurs, my numerator is only 0 when x is negative 3. So if I'm positive out here, I can't ever dip below the x-axis. So I know that I'm just going to tend towards my asymptote, right, as x approaches infinity. And similarly, up here, as x approaches infinity, I'm also going to approach the asymptote. We've already done that work. Now let's skip in between 0 and 2. Well, what about 1? What happens when x is 1? Well, if I plug in 1, I'm going to get a positive value in the numerator. In my denominator, I'm going to get 1 minus 1, which is 0, minus 2. So I'm going to have a negative value. All right, so I'm going to have some sort of negative value. I'm, going to be liberal with it. And remember, I can't cross the x-axis anywhere because I've already found all my roots. So on this side, I must be tending towards my asymptote going down, going towards negative infinity. And now let's consider on the other side. What's happening between 0 and negative 1? Well, why don't we plug in negative 0.5? Think about that very quickly. The numerator will be positive. My denominator, a negative 0.5 squared. And this might take a little work. You might want to jot this down. So I'll have a positive number in my denominator, or my numerator. In my denominator, I'll have negative 0.5 squared, which is 0.25, minus plus 0.5, because a negative 0.5 times a negative will be positive, minus 2. And so this is, minus 2 is going to overweigh it, and I'm going to have a positive over a negative, which is going to be a negative. So again, I'm going to be negative down here, and so I can't cross the x-axis again. That's really the key point here, is once I've found all of my roots, I know that I can't cross the x-axis again. Okay? And we're almost there. Now between -1 and -3, let's try -2. And if I plug in -2, notice that I'm going to have a positive value up top. -2 squared is 4, plus 2 is 6, minus 2 is going to be positive. So I'm going to have a positive value between -1 and 3. Right there. And so I know that I'm crossing the x-axis at -3. It hits the x-axis at -3. And before that, it's got to be tending towards positive infinity, because there's no way that I could duck back down, because this is my only root. And so now the only question is, do I bounce off and continue, then approaching 0 from the positive side, or does it cross through and then approach 0 from the negative side? And so to test that out, we know this is positive. We plug in some value on the left of -3, so try -4. We get a negative value up top, and then you can see that it's going to be a positive value, because -4 squared plus 4 minus 2 is going to be positive, so I'm going to have a negative value on this side. And so I must cross through underneath, and think about that. You know that that's going to be negative, but you also know it's going to tend back towards my asymptote, because what my asymptote does tell me is that, hey, as x approaches infinity, my function gets closer and closer to 0. And so that is the graph of my function.